Okay, now that we've seen some basics on the limit laws and solving or finding limits algebraically, we're going to look at now some examples, okay? And basically, first I'm going to introduce you to the four techniques that we're going to be using here, okay? So I'm going to just list them. We're going to be using four techniques, four possible techniques to solve the limits that we're going to meet from here on. And the first one is going to be substitution, okay, or direct substitution, where we are just going to put the limit we are approaching. Okay, the first one will be direct substitution, and we are going to put the limit we are approaching. We are just going to feed it into our function and we'll get an answer. Then the second method is going to, so direct substitution is like for basic polynomials, and you're going to see it in rational functions. Then the second one would be canceling out a common factor, okay? Canceling out a common factor. So we are going to use this one again. And then the third one is going to be simplifying, okay? It's still in algebra and we are going to be simplifying. And the fourth and final one is going to be rationalizing. So now let me just explain something here. You see these four methods. Basically, the types of questions we are going to meet are either going to be a polynomial, which we know what a polynomial is, right? Something like 5x squared plus 3x minus 9. This is a polynomial function, so we could say f of x is equal to that. So something like that. We don't even care what it's going to be like, what it's going to really look like. So one of the questions, either it will be a polynomial or it will be a rational function, okay? Or it will be a rational function. And we're going to be finding limits for these two guys. Now, direct substitution is going to be used for polynomials or rational functions, okay? But the rational functions we're going to use are going to be the basic ones with nothing complicated and no problems for us. But now the next two, the next three methods, which is method 2, 3, and 4, are going to be for rational functions, okay? Rational functions where we will be having a problem. Okay, they're going to be for rational. Remember that the methods are for either polynomial or rational functions. Okay, and we said polynomial, we are going to always use method 1, which is direct substitution. And then if we don't have a problem, we use direct substitution again for rational. But other than that, everything else is going to be we are going to apply it on rational functions, cancelling out a common factor, simplifying, okay, expansion and simplification, expanding and simplifying, and then rationalizing, right? So let's go through some questions which we are having here. Number 1, okay, it's the question is saying find what? What is 1? The limit as x approaches 3 of this rational function. You see 2x squared, 2x cubed minus 10x minus 8. So if I were to write that, I'm writing it, limit as x approaches 3 of this 2x cubed minus 10x minus 8. I'm going to first apply the limit laws. So it's going to be the limit as x approaches 3, we do one thing at a time, of 2x cubed, right? And then we say minus the limit, okay, the limit as x approaches 3 of 10x, and then minus the limit as x approaches 3 of 8. So we have these three things, right? Of 10x and then minus the limit as x approaches 3 of 8. Can you see that? Okay, so now we just go on and feed, because our this is a rational function. It was a rational function. So all I did was to feed in. We are going to, okay, first before I feed in, first thing that I did was to use the law, one of the laws, which was the law of sums, or the rule of sums, which was saying that when the things are adding, and the rules of differences also, when the things are adding, you can get their limits separately. So when it's like this, we can now get the limit. Or we could have just done it in one step. Okay, I'll show you at the end. So here we're doing it step by step. Now what do I do when it's like this? I just start feeding in my limit. Okay, I know that the limit as you approach a variable x, you just feed in the value into your variable. So I'm going to say 3 into this x. So it's going to be, my solution will be 2 here. I'm going to feed, okay, into this x. So it's going to be 2, this 2, times, instead of x we have 3 cubed. Then minus, in here we have minus 10x, which is I'm going to feed this 3 where there is x. Wherever there is x, I just feed the number. So it will be minus 10 by 3, okay? Minus the answer of 10 times 3. and then minus the limit as x approaches 3 of a number. The limit of a number is the number, so it is minus 8. And we go ahead and get the number. So if you say 3 cubed, you're going to get 27, right? And if you say 27 by 2, you should get 54, right? Now, when you get 54, you say minus 10 times 3, which is 30, and minus 8, right? And you get 24 minus 8 is 16, and that'll be your final solution. If you wanted to get it in one stage, you'd say the limit as x approaches 3 of 2x cubed minus 10x minus 8. You'd just use the method of direct substitution because this is a polynomial. You just get 2 by 3 cubed, right, minus 10 by 3, and then minus 8. Okay, we use the method of direct substitution, and you'd get the same answer of 16. Okay, now let's go to that second one. So I would recommend you use this first one related to your lecture slides. Let's see this one. Limit as x squared as x approaches negative 1 of x squared plus 5x over x to the power 4 plus 2. So here, all we're going to do is we are going to try and feed negative 1 into our rational function and see if the denominator is going to give us 0. If we say negative 1 to the power of 4, any number to a positive or to an even power will become positive. Any number to an even power will become positive. So I'm going to x to the power 4 is like saying negative 1 all to the power 4, you get just 1. And you say 1 plus 2, you get 3. So that means, okay, it's fine. I can use direct substitution because putting this negative 1 in my function will not cause a problem by making the denominator be 0. So I'm going to say this is going to be equal to, well, you could do it to say, you could use all the laws to say this will be the limit as x approaches negative 1 of x squared plus the limit as x approaches negative 1 of 5x divided by the limit again as x approaches 1 of x to the power 4 plus the limit again as x approaches negative 1, not 1. The limit as x approaches negative 1, right, on, and this is going to be the limit for 2. The limit of 2 as x approaches negative 1. Now we start to find our values. The limit of x squared as x approaches negative 1, you just replace. It will be negative 1 squared plus the limit of 5x, we are putting negative 1 where there is x, so it will be 5 by negative 1 over the limit of x to the power 4, it is negative 1 to the power of 4, right? It's negative 1 to the power 4 plus the limit as x approaches 2, the limit of a number is just a number. Minus 1 squared is 1. Then 5 by negative 1 is negative 5 over minus 1 to the power of 4 is 1 plus 2. So it will be plus 2. And it is 1 minus 5 is negative 4 over 1 plus 2 is 3. So it will be negative of 4 over 3. That's your final solution and you are done. So from here we learn a principle. Whenever you are starting to do with rational functions, because the next methods we're going to have a rational function, which is a fraction function. There'll be a fraction. Now, first thing you're going to do is test if the limit you are approaching makes the denominator 0. If it doesn't make the denominator 0, then go ahead and plug it in and find the solution. You use the method of direct substitution. But if it makes the denominator 0, then we start applying the techniques. Let's see them. First one, here we have a function. The limit as x approaches 2 of x squared minus 4. So what would happen if I put this x is approaching 2? Yes, so what will happen if I put 2 in the denominator? It becomes 2 squared minus 4. And what is 2 squared? It's 4. Minus 4, it's 0. So my denominator will become 0. And that should never happen. Even when the numerator is 0. The denominator should never be 0. We don't care what is in the numerator. 0 over 0 is not 1. 0 over 0 is undefined. So we must never have that situation. So as long as I see that, oh, putting 2 will make my thing 0, then that means we're going to have to find techniques. And the technique in here would be to factorize. Okay, you check, can you factorize it? Yes, I can. I'm going to have x minus 2 on the top over. On the bottom is the difference of 2 squares. If you're not quite familiar with that, I recommend you check the video on factorization. So it's going to be the difference of 2 squares, x squared, the square root is x, for the square root is 2. So I'm going to make 2 brackets, one saying x plus 2 and the other one saying x minus 2. Okay, and remember that it's not just, the fraction is not just there. I forgot, which should never happen to you. you should remember that you are not just putting the fraction or trying to get something, you are getting the limit. So I should move it away, like, let me move it. Wow, really? I'm going to try and move it. Ish. Sorry. My apologies. I'm going to highlight it, then move it. And I'm going to say this is going to be the limit as x approaches 2 of that. And what is this going to be now? When it's like this, we can now cancel the x minus 2 and x minus 2, and we'll get limit as x approaches 2 of 1 over x plus 2, right? Of 1 over x plus 2. Now, what is this going to be? I now have a rational function. Yes, I have a rational function. But now if I put in 2, it's not going to give me any problems. So now I continue. It's going to be, if you want to just be fancy, you could do it to say it's going to be the limit as x approaches 2 of 1 divided by the limit as x approaches 2 of x plus the limit as x approaches 2 of 2. And this is going to be the limit as x approaches 2 of 1. The limit of a number is the number comes back, so it is 1 over the limit as x approaches 2 of x. Where there is x, I'm just going to put 2, and then plus the limit as x approaches 2 of 2. The limit of a constant is just a constant, so it will be equal to 1 over 4. Okay, now that's it. You see, factorizing helped us remove something, and we're able to find our solution. Never forget that. What is the other way? Simplifying. Let's see. Can we factorize here? No, we can't. We are going to go ahead and expand. So it's going to be limo as x approaches 0 of 3 plus x all squared. We start with that, right? This is going to be 3 squared, which is going to be 9. Remember how you get it. You're going to say 3 squared. You square the first one, which is 9. Then you multiply these two together. 3 by x, you get 3x. The answer you get, you multiply by 2 because you're going to get 2 of them. It's going to be plus 6x. Then you square the last number, it's going to be plus x squared. And then you say minus 9 all over x, which is going to be limit as x approaches 0 of 9 minus 9 is going to be 0. You're going to remain with 6x plus x squared, or like this, and it'll be over x. Now, once it's like this, we can go ahead. We are saying the limit as x approaches 0. But what we can see is here, we can say it's the limit as x approaches 0. We see that we have a common factor on the top, and that's an x. We'll factor it out. We'll remain with 6 plus x divided by x. And the x and x will cancel, and you remain with limit as x approaches 0 of 6 plus x. Right? So it's going to be of 6 plus x, and what we're going to do is just to feed in now, because putting 0 won't affect anything. It's now a polynomial, so I'm going to put it. All right, this is like the last thing. Okay, this is like the last case you could get, and it is when you have a square root on top and you have something. Okay, the moment you see yourself having a square root in the numerator, what are you going to do to this? Because look, remember, the first thing we try all the time before we do anything to our functions, we try to put 0 in the denominator. The value that we are approaching, we try to fit it in the denominator. If the denominator goes to 0, then we know we have to do something. So if I put 0, it's going to be t squared is going to be 0, and my denominator will stay as 0, and that's a problem. Should never happen. So what should I do now? Rationalize. How do I do it? I multiply by the conjugate. What's the conjugate? It is the same thing as your numerator, but this sign, the values are the same. It's going to be square root of t squared plus 9 and 3, but the sign here at the center is going to be the opposite. And I multiply both the top and the bottom. So it's going to be, I'm going to multiply by the root of t squared plus 9 and then plus 3 over the square root of t squared plus 9 and then plus 3. This is going to be equal to, what is it? It's now equal to the limit. Never forget to say the limit as t approaches 0, because you're getting limit. Now, what do you get on the top? The top is going to be the easiest part, because you're going to say, I multiply the roots, the first thing, which is the first thing, the roots. And when the roots multiply, if you say root 2 times root 2, okay, your answer will be just 2. The roots go. So it's root of t squared plus 9 times root of t squared plus 9. Your answer will be just t squared plus 9. And then the next thing is, now you multiply the last things. Negative 3 times positive 3. Your answer is negative 3 by 3 is 9. And then the denominator, what is the denominator going to be? T squared is just multiplying this thing. So it'll be t squared multiplying the root of t squared plus 9. And then what is it? Plus 3. Okay, that is going to be. And what is your answer going to be? It's going to be limit as t approaches 0. And what is the top? T squared plus 9 minus 9. 9 minus 9 is 0. So it's going to be t squared all over t squared multiplying. Okay, t squared is multiplying the square root of t squared plus 9 and then plus 3. Okay, now I want you to open your eyes. I want you to see. You see you have t squared on top and t squared at the bottom outside the fraction, so they can cancel each other. On the top you remain with 1. So I'm going to try to make this crayon white, not the one I was using. So it's going to be equal to the limit as t approaches 0 of the top is now 1 over the bottom is now just the square root of t squared plus 9 and then plus 3. Now can I fit 0? If I put 0 to be 0 squared plus 9 is just 9. So it's now it's nice. So it's going to be equal to 1 over 0 squared plus 9, the root of that. And then you say plus 3. So it's going to be equal to 1 over 0 squared plus 9 is just 9. So the root of 9 and then plus 3. It is going to be 1 over the root of 9 is 3 plus 3 is going to be 1 over 6. And you are done. That's how you get the answer for this one. And that's it. Thanks for watching. We'll see you in the next video as we do more and more things and add to our knowledge. Bye for now.